Now let's look at what are the features of Java. First of all, we know that Java is an object-oriented language. Java is almost a purely object-oriented language. One example of purely object-oriented language is Smalltalk. What do I mean by purely object-oriented language is that a purely object-oriented language treats everything as an object. Okay? Now Java is almost a purely object-oriented language. Now what is missing therefore? First of all, everything here in Java is also treated as objects, except that we do have primitive data types. Okay? Second, we know Java for its platform independence. And architecturally neutral. So Java is platform independent as well as architecturally neutral. Now what do I mean by this? Platform independence means Java program, when you write the code and compile the program, still you are able to take that compiled program and run it on any platform, that is any OS. Okay? So it is independent of the OS. Now what makes it independent, we'll talk about it a little later. And it's architecturally neutral, which means on any hardware it works. So Java works with 32-bit platform onwards. So what makes your Java platform independence? It is the JVM, that is the Java virtual machine, and the bytecode. Now when you write a Java program, you compile it. When you run that compiled code, that code is presented to the JVM, it's loaded into the JVM. The JVM converts the compiled code into a machine code and executes it. Now when you compile a Java code, you get what is known as a .class file. And this .class file consists of what are known as a bytecode. The reason for this name is that the instructions, when you compile it in the class file, it is written in terms of a byte data type. So hence the name bytecode. Okay? And it is this bytecode which the JVM understands. So bytecode is an intermediary code, okay, which the JVM understands. Apart from these, the other features are, we have the concept of packages. Packages are nothing but directories in a file system. It's like a library or a collection of set of related class files. So we will talk about each one of these features later, but right now we are just going to mention the feature and a one-line definition. Interfaces. Now we need to remember here in Java, we have a single multi-level inheritance. In other words, you can have class A. From class A you can derive class B, class C, class D, likewise. So it's multi-level single inheritance. Of course you can have class A inheriting from class A like this, but we cannot have multiple inheritance. For example, I cannot have A and B both being parent to C. This is not allowed in Java. The complexities of C++ have been reduced in Java by avoiding certain features like multiple inheritance. Because in Java there is no way of saying, if suppose in class A I had a function f1, class B also has a function f1. Now class C, how do I resolve which function I am talking about, whether it's coming from A or B? So all this has been removed. So therefore it's single multiple inheritance in Java. Now interfaces are nothing but purely abstract class types in Java which can be multiply implemented on a Java class. So interfaces are used for dynamic binding. You cannot really say that it is used as a replacement for multiple inheritance, because when we talk about multiple inheritance, we would like to inherit the defined contents as well. But interfaces, as we said, are purely abstract. There is nothing defined in an interface. We'll look at that again later. There are no pointer concepts in Java. In other words, the programmer cannot use pointers, but internally, of course, Java does use pointers. As we mentioned, that when you create a variable for a class, when you create an instance, the variable is on the stack and the instance members get their memory allocation on the heap, and the object variable is actually pointing to the memory on the heap. So it actually has to be a pointer which is pointing, but that's all internally used. As a programmer, we cannot use pointers in Java. So since there are no pointers to be used, if you want to use system resources, if you want to access to the system resources, you require pointers. So how do you make use of it? You have a concept of JNI, that is Java Native Interface, using which you can access to the system resources. Exception handling. You might get errors at runtime. For example, we mentioned before when we were talking about abstract classes and dynamic binding, we said in case you are trying to downcast a parent object variable into a child class type, if you are going to downcast it into a wrong data type, wrong class type, you get a class cast exception, that is a runtime error. At the time when you are running your program, you get an error. Okay, that's called as a runtime error. So that's nothing but exception handling. You need to handle using exception handling concept. For example, errors, let's say you're trying to divide a value. If you're dividing a value by 0, you get an error. You're trying to access a variable which is not actually having any reference, you get an error. You're trying to access a file which does not exist, or you're trying to read a file beyond the length. You're trying to access an array beyond its length. These are all errors which occur at runtime, because you cannot find these out at compilation time. So such errors can be handled using exception handling. Then we have multi-threading. So multi-threading is another concept or a feature which actually lets you make use of your CPU time in a better way. Okay, it lets you parallelly execute two paths of execution which are functionally independent of each other. Then of course we have two types of programs that we can write out here. One is called as an application program. This is in terms, we are talking about in terms of a client program, and an applet program. An application program is a standalone program, whereas an applet is a web client. So it runs on the browser. An application, since it's a standalone program, standalone programs always have to start at a particular point, and that's nothing but the main function. So we need to have a main function in case of an application program, whereas in case of an applet it has its own life cycle. So these are some of the features of Java. We'll be looking at the other things which are the advanced features later.